Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2019, so let's get started. First problem, Alicia had two containers. The first was 5/6 full of water and the second was empty. She poured all the water from the first container into the second container, at which point the second container was 3/4 full of water. What is the ratio of the volume of the first container to the volume of the second container? Okay, so let's say that the first container's volume is V1 and the second container's volume is V2. So that gives us that 5/6 V1 equals 3/4 V2, right? And so multiplying 4 here and multiplying 6 here, then that gives us that 20 V1 equals 18 V2. And so since what we want is V1 over V2, so V1 over V2, this is equal to 18 over 20, which is equal to 9 over 10. So the answer is D. Number 2, consider the statement if n is not prime, then n minus 2 is prime. Which of the following values of n is a counterexample to this statement? Okay, so for a counterexample, then what we want is n is n is not prime, but n minus 2 is not prime, right? So both n and n minus 2 are not prime. And so A and C go out because they are just prime, and then we have to do n minus 2. So this is 13, this is 19, and this is 25. And so n minus 2 is not prime. The only value is 25, and so the answer is E. Number 3, in a high school with 500 students, 40% of the seniors play a musical instrument, while 30% of the non-seniors do not play a musical instrument. In all, 46.8% of the students do not play a musical instrument. How many non-seniors play a musical instrument? Okay, so let's say that there are X seniors, and so that would give us that the students who do not play a musical instrument, that would be 40% play, so for 60% don't play. 0.6 times X, they don't play, right? And then for the non-seniors, 30% don't play, so plus 0.3 times 500 minus X, right? And so this is 46.8%, which is 0.468, and then of 500 students. And so this much is equal to 500 is half of 1000, so this is equal to 200, and so that is equal to 234 students. And if we multiply by 10 on the left side and the right side, then we will get rid of these two 0 points, and then we will add 1 0 at the back, right? And so like that. And so if we expand this now, we will get that 6x plus 1500 minus 3x equals 2340, and so 3x equals 2340 minus 1500, which is 840. And so x will equal 260, right? No, 280, right? And so x is the number of seniors, and then we want the number of non-seniors that play a musical instrument. And so since 30% of the non-seniors don't play, that means 70% plays, and so we need 0.7 times 500 minus 280, which is 220. So this is 7 times 22, which is 154. So the answer is 154 people. It's B. Number 4, all lines with this kind of equation, such that ABC form an arithmetic progression, pass through a common point. What are the coordinates of that point? Okay, so since ABC they form an arithmetic progression, then A and B and C they would just be the same as B minus D, no, B minus X. So no, X and Y are taken. B and K, B and B plus K, right? And so if we put in those, then B minus KX plus BY would equal B plus K, right? And so X equals minus 1, right? Because because minus KX has to be plus K, and so X equals minus 1, and so minus B plus K plus BY equals B plus K, and so Y should equal 2, right? And so X is minus 1 and Y is 2. So the point is -1, 2. So the answer is A. Number 5, triangle ABC lies in the first quadrant. Points ABC are reflected across the line y equals x to points A prime, B prime, and C prime respectively. Assume that none of the vertices of the triangle lie on the line y equals x. Which of the following statements is not always true? Okay, so let's try to draw this. So we have a coordinate plane, and we have y equals x, right? Because that's where the line is reflected across. So this would be y equals x, and then let's say that ABC looks like this. No, it would look like this. And so this would be the reflected triangle, right? And so since none of the vertices of the triangle lie on y equals x, then let's look at the answer choices. Triangle A prime, B prime, Z prime lies in the first quadrant. Yes, this is always true because the first quadrant itself flipped upon y equals x. That is just also the same thing, just the first quadrant. And so A is always true. And triangles ABC and A prime, B prime, C prime have the same area. Obviously, that's true. Number C, the slope of A prime is -1. So let's say that this is A, then this would be minus A. No, then this would be A prime, right? A prime, right? And since we so since we reflected over y equals x, then the slope of this line, that would be so that would be a right angle to y equals x. So the slope of that would be -1. So C is also true. And D, the slopes of line A prime and C prime are the same. Yes, so like this would be C prime, and so this would also be -1, and this would also be -1. So they are the same. So D is also always true. And E, lines AB and A prime B prime are perpendicular to each other. So let's see, this is B prime, and obviously these two lines are not perpendicular, right? So the answer is E. Number 6, there is a real n such that this is satisfied. What is the sum of the digits of n? Right, okay, so first of all, we can divide everything by n factorial. So that will get us n plus 1 plus n plus 1, n plus 2, n plus 2 equals 440. And so if we like take out n plus 1, that will be n plus 1 times n plus 1 times n plus 3. This equals 440, but then 440, this is equal to 20 times 22, right? And so so if n plus 1 equals 20 and n plus 3 equals 22, then n equals 19. So 1 plus 9, the answer is 10. It's C. Number 7, each piece of candy in a store costs a whole number of cents. Casper has exactly enough money to buy either 12 pieces of red candy, 14 pieces of green candy, 15 pieces of blue candy, or n pieces of purple candy, and a piece of purple candy costs 20 cents. What is the smallest possible value of n? Okay, so this gives us that the amount of money that Casper has in cents is a multiple of 12, 14, 15, and 20, right? And so since we want the smallest possible value of n, we want the least common multiple of 12, 14, 15, and 20, and so that will be 3 times 4 times 5 times 7, right? And so this would be equal to 20 times 21, because this is 20 and this is 21, and n pieces of purple candy, and a purple candy costs 20 cents, so that means n times 20 equals this much, which is 20 times 21. So these two cancel, n equals 21. The answer is B. Number 8, the figure below shows a square and 4 equilateral triangles, with each triangle having a side lying on a side of the square such that each triangle has side length 2, and the third vertices of the triangle meet at the center of the square. The region inside the square but outside the triangles is shaded. What is the area of the shaded region? Okay, so for us to get the area of the shaded region, we have to first get this whole square, and then we have to subtract 4 of these equilateral triangles, right? And so since each triangle has side length 2, that means this is 2. So thus, this length must also be 2. And if we draw a line from the center to the midpoint, then this would be a 30, 60, 90 triangle, right? So if this is side length 2, then this would be side length 1, and this here would be root 3. Right, this would be root 3. And so since this would be the same length, this is also root 3. That means this whole thing, so this whole thing is going to be the same thing as root 3. No, it's going to be 2 root 3, right? That would be 2 root 3. And so the whole circle, the whole square is equal to 2 root 3 squared, which equals 12, right? And now we have to subtract 4 of these triangles. And so one triangle is so one triangle is 1 times root 3, right? And so one triangle will be root 3, so 4 times root 3, that will be the 4 triangles. So our total answer is 12 minus 4 root 3. That is 12 minus 4 root 3. The answer is B. Number 9, the function f is defined by this thing. For all real numbers x, where r floor denotes the greatest integer less than or equal to the real number r. What is the range of f? Okay, so since this yeah, so since this value includes like our floor and the absolute values and things like that, first we will have to see the case where x is an integer, right? So if x is an integer, then yeah, so then the absolute value of x and the floor of that will be so that will be same as the floor, yeah, the absolute value of the floor of x, right? So that will just give us 0. And if x is not an integer, but if x is greater than 0, right, and yeah, and it's not an integer, then this will give us yeah, so let's try it with an x value like 1.5, right? If we put 1.5 into here, then the absolute value of 1.5 is just 1.5, and the floor of that will be 1, right? But then for the floor of 1.5, that will be just 1. Yeah, that will be just 1, and the absolute value of that will also be 1. So that's just 1 minus 1 equals 0, and so this also gives us 0. And then lastly, if x is less than 0, and it's also not an integer, right? But then this time, let's try x equals negative 1.5, right? So if negative 1.5 goes in, the absolute value of negative 1.5 is 1.5, and the floor of that is equal to 1. And the floor of negative 1.5, that's negative 2. And the absolute value of negative 2, that's 2, right? So that gives us just 2. And so 1 minus 2, that's negative 1, right? So this gives us negative 1. So all the f values that we can get from all real numbers x is just 0 or 1. No, just 0 or negative 1, right? So the answer is A. Number 10, in a given plane, points A and B are 10 units apart. How many points C are there in the plane such that the perimeter of triangle ABC is 50 units and the area of triangle ABC is 100 square units? Okay, so let's say that point A and B is this point, right? Yeah, let's say it's this point. And so A and B, they are 10 units apart, right? And then so the perimeter being 50 units, and the area being 100 square units, those are two entirely different conditions, right? And so for the area to be 100 square units, that means that the height needs to be 20, right? And so for the height to be 20, there are two possible lines, and for this one, those are this line like that, and the same line like that, right? And so this length will be 20, and this length would also be 20, right? Because that way, if we have point C on any one of these red lines like this, and then this will be 20, so the height will be 20 and the bottom will be 10, so the area will be 100, right? And the next thing is for the perimeter of ABC to be 50 units. That means if we have like AA value C, like that, then AC plus BC would have to be 40 because AB is 10 already. And so that is an ellipse because we need the sum of the values to a certain point, they have to be the same, right? And so that will be an ellipse like this. And so for ABC to be 50 units, then this would be the highest point of C, right? And so there, BC would be 20 and AC would also be 20, right? And AC would also be 20. And so that means if we divide this in half, then this much would be 10 divided by 2, which is 5, right? And so this much is 4, no, so that much is 4 to 1 to root 15, and so this much is 5 root 15. 5 root 15, and so 5 root 15, this is less than 20, right? And so therefore, this ellipse and these lines, they can never meet. So a point C that satisfies both this condition and this condition cannot exist because there is no intersection point. So the answer is 0, it's A. Number 11. Two jars each contain the same number of marbles and every marble is either blue or green. In jar 1, the ratio of blue to green marbles is 9 to 1, and the ratio of blue to green marbles in jar 2 is 8 to 1. There are 95 green marbles in all. How many more blue marbles are in jar 1 than jar 2? Okay, so since they each contain the same number of marbles, and so jar 1, we have jar 2, right? And so for jar 1, the ratio of blue to green is 9 to 1. And for jar 2, it's 8 to 1, right? but then the number, so the total number has to be the same. So we have to multiply 9 to this, and we have to multiply 10 to this, right, to make the sums the same. So this will give us 81 and 9, and this one will give us 80 and 10, right? And so the sum of these numbers, they are equal. That's why we did the multiply by 9 and multiply by 10, right? But then since there are 95 green marbles in all, and this side is the green side, so for these amounts right now, we have 17. And so 19. So right now 19 times 5 equals 95, and so for there to be 95 green marbles, then the total amount needs to be multiplied by 5 on both sides, right? And so how many more blue marbles in jar 1 than in jar 2? Okay, so for jar 1, so for jar 1, we have 5 times 81 blue marbles, and jar 2, we have 5 times 80 blue marbles, right? And we have to find the difference, and that's just 5. So the answer is A. Number 12, what is the greatest possible sum of the digits in the base 7 representation of a positive integer less than 2019, right? So since it has to be a positive integer less than 2019, then the highest it can be is 2018, right? And so the base 7 representation of 2018, that would be 2018 base, so this would be equal to something plus something times 7 plus something times 7 squared plus something times 7 cubed, and then so on, right? And times 7 to the 4th power, right? But then so if you calculate this, then this would be just 2, and then 2 plus 1 times 7 plus 6 to the 7 times squared power, and then 5 times 7 to the 3rd power, and that will be the end, right? And so we have 5, 6, 1, 2, so that is 5, 6, 1, 2 to the, so this is the base 7 representation of 2018, right? So what we want is the greatest possible sum of the digits, right? And so so the number has to be less than 5,612, and so the highest sum of the digits this can give us is either 4666 or 5566. Either way, they give the same value, which is 22. And the only way to get a sum of the digits that are greater than these two numbers, that is only by doing 5666. But then since this is more than 5,612, that's not possible, right? And so 22 is the best we can get. The answer is C. Number 13, what is the sum of all real numbers x for which the median of the numbers 4, 6, 8, 17, and x is equal to the mean of those 5 numbers? Okay, so we have 3 kind of choices. The first is where 6 is the median. Where 6 is the median, right? And then the next is where 8 is the median. And the last is where x itself is the median, right? And so for 6 to be the median, we have x is less than 6, right? And for x is less than or equal to 6. And for 8 to be the median, we have x is greater than or equal to 8. And for x to be the median, this gives us x is greater than or equal to 6 and less than or equal to 8, right? And so these are the conditions, and if we calculate it, if 6 is the median, then the median is also the mean, right? And so the 5 numbers, so that means there will be 30 in total. So x equals 6 times 5, which is 30, minus 4, 6, 8, 17. And the sum of these 4 numbers, it's 35, right? And so this would be 30 minus 35, and so x equals negative 5, right? And so this works. And if 8 is the median, then x would have to be 8 times 5, so that would be 40, minus 35, this is 5, but then x has to be greater than or equal to 8, right? So this doesn't make sense. And if x is the median, then x would be equal to 5 times x, so that would be 5x minus 35, right? And so 35 equals 4x. X equals 35 over 4, which is equal to 8, which is 8, which is equal to 8 and 3 over 4, right? And so this is 8, so this is greater than 8, but then x has to be between 6 and 8, so this also doesn't work. So the only real number x that works is -5, so the answer is A. Number 14, the base 10 representation for 19 factorial is this thing, where t, m, and h denote digits that are not given. What is t plus m plus h? Okay, so for this problem, first of all, we can know what the value of h is, right? Because 19 factorial includes 5 and 10 and 15, so there are three fives, and there are more than three twos, right? And so that means that there are at least, so that means there are 3 tens. And so the last 3 digits are all going to be 0, 0, 0, right? And so the last three digits are h, 0, 0. That means h equals 0. And so h is 0, and so we just need to care about t plus m, and h is just 0, right? And next is t and m. And so since 19 factorial is a divisor of 3, that means this should be divisible by 3, right? And so the divisibility rule for 3 is that the sum of its digits must also be a multiple of 3. And so if we just add the digits together, 1 plus 2 plus 1 plus 6 plus t plus 5 plus 1 plus 0 plus 0 plus 4 plus m plus 8 plus 3 plus 2. This has to be a multiple of 3. Right, so this has to be a multiple of 3, and 3 is already a multiple of 3. 1 plus 2 is already a multiple of 3. 6 is a multiple of 3. 5 plus 1 is 6, so that's a multiple of 3. And 4 plus 8, that's a multiple of 3 because it's 12. And 1 plus 2, that's also a multiple of 3 because that's 3. And so that just leaves us with t plus m. So t plus m, this is a multiple of 3. A multiple of 3. And next, we also know that 19 factorial includes 11, right? And so if you know the divisibility rule for multiples of 11, it's that, so the divisibility rule for 11, this is that their alternating sum is a multiple of 11. And what I mean by alternating sum, that just means that it just means it's 1 minus 2 plus 1 minus 6 plus t minus 5 plus 1, and then minus 0 plus 0 minus 4 plus 0 minus m plus 8 minus 3, and then minus 3 plus 2. And so that will be a multiple of 11, right? And so 1 plus 1, so 1 minus 2 plus 1, that's 0, so we can just take that away. And what else can we take away? We have plus 1, plus 2, and minus 3, so we can take those away. And yes, and plus 8 and minus 4, that just leaves plus 4, right? And then plus 4 and minus 5, that just gives minus 1. And so minus 1 and minus 6 together, that will just be minus 7. And so and so the value that we get is that t minus m minus 7, this is a multiple of 11, right? So t minus m minus 7, this is a multiple of 11, right? But since t and m are only digits, that means they are like one-digit numbers, right? And so for this to be a multiple of 11, the only way is for t minus m to be equal to 7, so that this is just 0, right? And so we have the fact that t plus m is a multiple of 3. So we have this, and we have the fact that t minus m equals 7. And so looking at the answer choices, we have two ways. Since t plus m should be a multiple of 3, then these can't be it, so it's either 3 or 12. And so if t plus m equals 3, then this means t is 5 and m is 2. And if t plus m equals 12, then this means that t equals 19 over 2. So this is not an integer, so of course t can't be this, and this makes sense. So t is 5 and m equals 2. That's when t plus m is 3, so the answer is A. Number 15. Right triangles T1 and T2 have areas 1 and 2 respectively. A side of T1 is congruent to a side of T2, and a different side of T1 is congruent to a different side of T2. What is the square of the product of the other third sides of T1 and T2? So let's first draw a quick diagram here. So that would be the diagram for T1 and T2, and so this would be T1 and this would be T2, right? and their areas are 1 and 2 respectively. And so this side is, yes, so this side is going to be equal to this side of T2, and this side of T1 is going to be equal to this side of T2, right? And so we want the square of the product of this side and this side, right? And so let's first say that that this length, it's A, so this would be A, and so therefore this would also be A, right? And since the area is 1 and 2, this area is 1, that means this area, yeah, so that length would be 2 over A. And since this area is 2, that means this length would be 4 over A, right? But then since we said that this length is equal to this length, that means this length over here is also equal to 4 over A, right? And one more thing we find is that since yeah, since the ratio of this length to this length is 1 to 2, that means, and this is, and that's a right triangle, so that means that this whole triangle is a 60, 30, 90 triangle, right? And so this would be 60 degrees, and this would be 30 degrees, and this would be a right triangle. And so therefore, this length is root 3 times 2 over A. So that means A equals root 3 times 2 over A, so A squared equals 2 root 3, so A is equal to 2 root 3 over A. And so if we put that in there, then that gives us that A is equal to 2 root 3 over A, and since this is also a right triangle, then this to this ratio is 2 root 3 to 4, right? And by the Pythagorean theorem, if this is 4 and this is 2 root 3, then this value, that must also be 2 root 7, right? And also this must be divided by 8 because all the other things have divided by 8, right? And so this length is 2 root 7 divided by 8, and this length is 2 over 8. And so we want the square of the product of the other third sides, and so we want this squared, no, we want 2 root 7 over A times 2 over A squared, right? So this is all over A squared, and this is 4 root 7. But then back then we saw that A squared equals 2 root 3, so if we put that in there, then that gives us A squared, which equals 2 root 3, which is 2 root 7 over root 3, right? And we want this squared. And so the final value would be 2 root 7 squared is 4 times 7, and all this is over root 3 squared, so that would be 3, right? And so this is equal to 4 times 7 is 28, so it's 28 over 3, so the answer is 28 over 3, which is A. Number 16. In triangle ABC with a right angle at C, point D lies in the interior of AB and point E lies in the interior of BC, so that AC is CD, DE equals EB, and the ratio AC to DE equals 4 to 3. What is the ratio AD to DB? Okay, so if we draw a diagram here, this would be the triangle, right? And so this would be the right angle at C, and then these two would be equal, and these two would be equal, right? And so since we have two isosceles triangles, then what we would first want to do is we want to put a line from C to the midpoint of A to D, so that this would be a right angle, and same thing for DEB, right? And so we want this line so that this is a right angle, and we want the ratio of AD to DB, so we want the ratio of this to this, right? And then next to notice is that this is a right angle. And like, how is it a right angle, right? But then we see that this angle and this angle is the same, and this angle and this angle is the same, right? And then this whole thing, it's the sum of the angles is 180, and so this is, since this is a right angle, then this plus this is 90 degrees, right? And so since the whole thing is 180 and this plus this is 90 degrees, that means this is 90 degrees also. And so that's how we got that. Next is that AC to DE equals 4 to 3. So AC to DE, this is 4 to 3, and so if this is 4, this is 3. If this is 4, then this is also 4. So this is also 4, and EB is also 3, right? And since this is 4 to 3 with a right triangle, that means this much is 5, right? So that's 5, and then we have the whole length AB, right, because of the Pythagorean theorem. And so we have 4 and we have 8, and so we have a right triangle with 4 and 8, then this will give us 4 root 5, right? And so the whole thing will give us 4 root 5, right? And the next, what we want is 2 root 5, right? Because 2 root 5 is half of that length, and so yeah, and so this length plus this length is 2 root 5, and so that much is 2 root 5. This much is 2 root 5, right? And the ratio of AD to DB is equal to the ratio of half of AD to half of DB, so that's equal to the ratio of this to this, right? And so if we know only this length and this length, or even one of the two, then we have our answer, right? And then next, let us notice that this angle, so this angle right here, that's also one of the red angles, right? Because if you see, this is also a right triangle with one angle right and one angle blue, and if you see, the whole thing is also a right triangle with one angle blue, and the other angle has to be red, and so that means this angle is also red. And so by that we can see that this triangle is similar to this triangle, right? Also, since it's similar, the length of the and also since it's similar, the ratio of the length is also similar, right? So this is 4 to 8, that means it's 1 to 2. That means the length of this to this is also 1 to 2, right? So this, yeah, so this is 1, this is 2, but then the hypotenuse is 4, and so that would mean that the legs would have to be lengths 4 over root 5 and 8 over root 5, right? Because this is 4 is equal to 4 times root 5 over root 5, right? And so since we have this length, then it's game over, right? Because if we have this length, then we can have this length also, and the ratio of that is the ratio that we want. And so this length will be 2 root 5 minus 4 over root 5, and 4 over root 5 is equal to 4 root 5 over 5. So this is equal to 2 minus 4 over 5 times root 5, which is equal to 6 over 5 root 5, right? And so we have 4 over root 5 and 6 over root 5, so the ratio is 4 to 6. The answer is 2 to 3. The answer is A. Problem number 17. A red ball and a green ball are randomly and independently tossed into bins numbered with positive integers, so that for each ball, the probability that it is tossed into bin K is 2 to the negative kth power, for K is 1, 2, 3, and so on. What is the probability that the red ball is tossed into a higher number bin than the green ball? Okay, so let's see the probability of being tossed into each bin. And so for bin 1, it's 1 over 2. For bin 2, it's 1 over 4. For bin 3, it's 1 over 8, and so on, right? We need to find that the probability that the red ball is tossed into a higher number bin than the green ball, right? But then if the green ball is tossed into, so if the green ball is tossed into bin 1, then the probability that the red ball is tossed into a higher numbered bin is everything after that, right? And everything after that adds up to 1 over 2, right? And so if green is 1 over 2, then red is also 1 over 2, right? And if green is tossed into a bin numbered 1 over 4th, then the whole thing is sum 1, and so the sum of the things higher would be 1 over 4 also, right? So that would also be the same as 1 over 4. Then the red ball would also be 1 over 4, right? And so on. And so we want the multiples of this. So this is 1 over 4, 1 over 16, and then after that is 1 over 64, etc., right? And so the probability that the red ball is tossed into a higher number bin than the green ball, that is these all added up, right? And so then we will get the first term is 1 over 4, so it's 1 over 4 over, and then it's 1 minus the common ratio is 1 over 4, so 1 minus 1 over 4, so this is 1 over 4 over 3 over 4. So the answer is 1 over 3. It's 1 over 3, which is C. Problem number 18. Henry decides one morning to do a workout, and he walks 3/4 of the way from his home to his gym. The gym is 2 kilometers away from Henry's home. At that point, he changes his mind and walks 3/4 of the way from where he is back towards home. When he reaches that point, he changes his mind again and walks 3/4 of the distance from there back towards the gym. If Henry keeps changing his mind when he has walked 3/4 of the distance toward either the gym or home from the point where he last changed his mind, he will get very close to walking back and forth between a point A kilometers for home and a point B kilometers for home. What is the absolute value of A minus B? Let's change this guy's name from Henry to Hamlet, right? And so if we have Henry's home here, home, and we have the gym here, and we have the gym here, like that, then he walks 3/4 of the way, right? So he walks this much, but then he comes 3/4 back, and then he goes 3/4 again. And so if this continues, then that means just he will cycle between 2 points, it said. So it's just between here and like here, right? And so he will just cycle between these 2 points. And that is only possible because this point, seen from this point of view, is the 3/4 point. And same thing for here. Seen from this point is the 3/4 point. And so that is only possible if our values are like this is 3 and then this is 1, right? Because that way the whole thing would be 4 and then this point would be at the 3/4 point. And same thing for here. If this is 1, then seen from here, then the whole thing is going to be 4, but then this point is going to be the 3/4 point, right? And so that will be our answer. And A kilometers from home and B kilometers from home. So if we look at the whole thing, this point will be 1/5 of the way, right? And this point will be 4/5 of the way. And the gym is 2 kilometers away. And so A and B is 2 times 1/5 and 2 times 4/5, right? And so the absolute value of A minus B is the absolute value of this minus this. And so that is equal to 5. So that is equal to 2/5 minus 2/5 minus 8/5. And so if we take these away, this will be our answer, which is 6/5. And this is which is the absolute value of -6/5, which is 6/5, which is 1 and 1/5. So the answer is C. Number 19. Let S be the set of all positive integer divisors of 100,000. How many numbers are the product of 2 distinct elements of S? Okay, so we know that 100,000, this is just 2 to the 5th power times 5 to the 5th power, right? And we want the numbers that are the product of 2 distinct elements of S. And for that, we can have 2 to the power of 0 to the 2 to the power of 10. Yeah, so 2 to the power of 0 to 10. And then 5 to the power of 0 to 10, right? And the reason that it's between 0 to 10 is because, like, what if we have like 5 to the first power and 5 to the third power, right? Then 2 could be 0. And same thing for 5 to the 0th power. What if it's 2 to the first power and 2 to the third power? Then 5 would be to the 0th power. And same thing for 10. If it's 2 to the 5th power times 5 and 2 to the 5th power times 5 squared, then that would also count. So we need 10. And same thing for 10 for the 5, right? So we want the numbers that are the product of 2 distinct elements of S, and so we have to multiply these two. So this is 11, and this is 11 possibilities each. So that's 11 squared. So 11 times 11 equals 121, right? But then that's not all, right? Because we have 2, 0 and 5, 0 in there. We also have 2, 0, 5, 10 in there. We also have 2, 10, 5, 0 in there. And we have 2, 10, 5, 10 in there, right? But then this can only be gotten by 1 times 1, and we can't be the same, right? Because it's 2 distinct elements. And so 1 times 1, so this is not possible. So we have to take this one out. And for this one, this is only by 5 to the 5th power times 5 to the 5th power. And it also has to be 2 distinct elements, so that's also not possible. So this is not possible. And this one, same thing, 2 to the 5th power times 2 to the 5th power. That's the only way, right? And so they have to be distinct. And so this has to go away. And for this one, lastly, this is 2, 5, and 5, 5 times 2 to the 5th power times and 5 to the 5th power, right? And so these two are the same things, but they have to be distinct. So this can't be it. And so we have to take out 4 from 121. So 121 minus 4, this is 117. And the answer is 117. It's C. Problem number 20. As shown in the figure, line segment AD is trisected by points B and C so that AB equals BC equals CD equals 2. 3 semicircles of radius 1 AEB, BFC, and CGD have their diameters on AD, and they are tangent to line EG at E, F, and G respectively. A circle of radius 2 has its center on F, and the area of the region inside the circle but outside the 3 semicircle shaded in the figure can be expressed in the form A over B times pi minus root C plus D, where A, B, C, and D are positive integers, and A and B are relatively prime, whereas A plus B plus C plus D. Okay, so basically we want the shaded area, right? So we want the shaded area. And so to get that, first we get the area of the whole circle. No, actually first we get the area of this half circle, and then we get the area of this part, and then lastly we get the area of this green part, right? And so that looks like a hamburger. If we try to get the red part first, that is just 1/2 of the whole circle, and AB equals BC equals CD equals 2. Yeah, so these all equal 2, and so therefore that means one radius equals so one radius is 1, and so from this point to this point, this is 2 radiuses, so that's 2 radii, so that gives us that the radius of the whole circle is 2, so 2 squared pi. This equals 2 pi, so the red part is 2 pi. And for the blue part, the blue part is basically this kind of fan-shaped thing. So it's this fan minus this triangle, right? And so the fan is 1/3 of the whole thing. So the fan is 1/3 of the whole thing. So that would be 1/3 times 2 squared pi, which is 4 pi. And then this minus, and then minus this triangle, right? And so that triangle, we can see that this much is 1, right? That much is 1, and this length, also, and this length is 2, right? Because that's the radius. And so therefore this length will be √3, because this is a right triangle, right? And so since this much is √3, that means this much is also √3, right? And so that would be 2 √3. And so this is minus, and then we have 1 times 2 3 times 1/2. So this is equal to 4 pi over 3 minus √3, right? And so this is our second part. So if we do that, then we will be getting, so the blue part, which is 4 pi over 3 minus √3, right? And then lastly we have the green part, right? And the green part is basically the area that is not part of the semicircles. And so if we have a square and if we have a circle like that, and then if we have the area that is not in the squares like this, the that exact sum is so they are these two parts, right? And so since one radius is a 1, and so this whole thing will be 2, so it's 4 squared, no, so it's 2 squared minus pi, so it's 4 minus pi. So the green ones will be 4 minus pi. And so if we add all of these together, then we will get 2 pi minus pi plus 4 over 3 pi, which is 7 over 3 pi. So it's 7 over 3 pi. And then we have minus √3. And then we have plus 4, right? And so we have our A, B, C, and D values. A, B, C, D, they are 7, 3, 3, and 4. So if we add all of these up, the answer is 17. It's E. Problem number 21. Deborah flips a fair coin repeatedly, keeping track of how many heads and how many tails she has seen in total, until she gets either 2 heads in a row or 2 tails in a row, at which point she stops flipping. What is the probability that she gets 2 heads in a row, but she sees a second tail before she sees a second head, right? Okay, so from this clause, she sees a second tail before she sees a second head. That means either she gets tail, and then she gets a head, or she gets tail and then a head, and then a tail, right? Or she gets a head and then she gets a tail and then she gets a tail, right? Those are the only 3 ways that she sees a second tail. But then she has to get 2 heads in a row, right? And so these and this are not possible because that gives 2 tails in a row and then she will stop, right? So we have only so our only way is starting with tail, head, tail, and then just keeping this pattern up, right? So we will start with tail, head, tail. But then since Deborah has to get 2 heads in a row, the smallest way that she can do this is head like that right away. And then next we can have tail head, and then tail head, and then head like that. And then next we can have tail head, tail head, tail head, tail head, tail. No, tail head, head, right? Because she has to end with 2 heads. And we can keep going like this, but then you see the pattern. We start with this, and then to this, we keep adding tail head, tail head, tail head at the front, right? And so this first possibility, this is 1 over 32, because 32 is 2 to the 5th power. And this one, this is what we keep multiplying. This is 1 over 2 to the 2nd power, so this is 1 over 4, right? And then what is the probability that she gets 2 heads in a row, and she sees a second tail before she sees a second head. And so so if you haven't noticed yet, this is going to be a geometric series because we have to add all of these values up. And our first and so our first value is 1 over 32. Our common ratio is 1 over 4, so it's going to be 1 over 32 over 1 minus 1 over 4, and so this is equal to 1 over 32 over 3 over 4, 1 over 32 over 3 over 4. So this is 3 times 32 over 4. And so if these cancel out, and then that will give us 8. So this is 1 over 24. So the answer is B. Number 22. Ration, Sylvia, and Ted play the following game. Each starts with $1. A bell rings every 15 seconds, at which time each of the players who currently have money simultaneously chooses one of the other 2 players independently and at random, and gives $1 to that player. What is the probability that after the bell has rung 2019 times, each player will have $1? For example, Ration and Ted may each decide to give $1 to Sylvia, and Sylvia may decide to give her dollars to Ted, at which Ration will have $0, Sylvia will have $2, and Ted will have $1, and that is the end of the first round of play. In the second round, Ration has no money to give, but Sylvia and Ted might choose each other to give their $1 to, and the holdings will be the same at the end of the second round, right? Okay, so we have Ration, Sylvia, and Ted. And they start with $1 each, right? But then we have to, we have to find out after like 2019 times, what will be the probability that each player will have $1, right? So let's just write out all the possible things that can happen if Roshan and Sylvia and Ted chooses different things. And since each has like 2 choices, we have just 8 things. So first we can have Sylvia and Ted can all give it to Rasha, and Rasha will get 2, and Roshan can give to either Sylvia or Ted. So if Roshan gives to Sylvia, it will be 1, 0. If Roshan gives to Ted, it will be 2, 0, 1, right? And same thing, now Sylvia can get everything. So if Sylvia has 2, then Sylvia can choose which one to give to. So 1 or 0, or 1, 0, like that. And the same thing for Ted. But the same reasoning, it's 2, 1, 0, or 2, 0, or 2, 0, 1, right? And then next, Roshan and Sylvia and Ted, they can trade in like this counterclockwise, no, in this clockwise manner, right? So Roshan can give to Ted, Sylvia can give to Roshan, and Ted can give to Sylvia, right? So that will just give everything at the same spot. So that will just keep everything at the same spot. So that's just 1, 1, 1. And lastly, if we go counterclockwise the other way, then that would just also be the same, right? And so in total we have 8 possibilities. So we have 8 total. But then for our 1, 1, 1, 1, 1, 1, we have two that we want, right? And this pattern is going to continue for everything. And since there are 2019 rounds, the probability that this will happen is going to get closer and closer to 2 over 8, right? So our final answer is 2 over 8, which is 1 over 4. So the answer is B. Problem number 23. Points A, 6,13 and B, 12,11 lie on circle omega in the plane. Suppose that the tangent lines to omega at A and B intersect at a point on the x-axis. What is the area of omega? Guys, so this is not W, that's omega, that's Greek letter. And so first, if we draw a diagram of this, then that would look something like this, right? And so we have our A and B points at, where is it, 6,13 and 12,11, like that. And we have this point C where they intersect, but then we don't know the coordinates of that point C, right? And so now what we have to notice is that we can have a middle value between A and B, right? So like right here, and from this line to C, this line, so the slope of that line will be perpendicular to the slope of AB, right? And so if we look for the slope of AB, then AB's slope is going to be this much is 2, this much is 3, so it's negative 1 over 3. So negative 1 over 3, and this and the negative reciprocal of negative 1 over 3 is 3, right? And so this is going to have a that's gonna have a slope of 3, right? So that's gonna be slope of 3 times y equals 3 times, and then the middle value is, what is it, 9 comma 12. So it's 3 times x minus 9 plus 12. So this is 3x minus 15, right? So this is 3 times x minus 5. So the x-intercept is 5. That means C, this value is 5 comma 0, right? And the next, we want the area of the circle. And so if we take this away, then our midpoint of the circle, that will be right here, so that's going to be the center of the circle, and obviously this value is going to be the radius, and so this value is going to be equal to it, right? And we have a right angle like that and like that because those are tangent values. And now the next thing we can see that is that this value and this value, they are equal, and their lengths is we have x is 1 and the y is 13. So rise over run, so rise is 13 and run is 1. And so the length between that will be root 13 squared plus 1, which is root 170, right? So that's root 170. And same for this thing, that's equal to it, so this is also going to be root 170, right? And then the most important thing that we need to catch is that this triangle right here, that's a right triangle, right? That triangle is similar to this triangle, and that is because they both have right angles like that, right? And they both share this angle, and so they are similar. And so this gives us the key to getting the entire problem, because since we know this point, right, then we know this because since we know this point, then we know this length, and we also know this length, right? Now, because we have the point C. And so we know this length and this length. And so the ratio of those lengths will be the ratio of the radius to AC, right? And so if we get A to this point, A to the midpoint right away, then that will be 6, 13 to 9, 12. So that's 3 and 1. So this is 3 and 1. So that's root 10. So that's root 10, and for here, it's going to be 4 and 12, so that's going to be 4 root 10, right? 4 root 10. And so now we know that the ratio of the lengths is this to this is going to be 1 to 4, and so this to this is also going to be 1 to 4, right? And so now we know that the radius, so the radius is equal to 1 over 4 times root 170. We want the area of omega, and so omega's area is pi r squared, and so this is pi times 1 over times root 170, so 1 over 4 times root 170 squared. So this is pi times 170 over 16. And so this is our answer, and we can finally just make some adjustments, so that will just going to be equal to 85 over 8, because we can divide both sides by 2. So the answer is 85 pi over 8. So the answer is C. Number 24, define a sequence recursively by x0 equals 5, and this is true for all non-negative integers n. Let m be the least positive integer such that this proves true. In which of the following intervals does m lie? And we have these intervals, and we can see that the interval size, they're very large, right? So first, we can look at this one, but then this is 1 over 2 to the 20th power. That's a very nice number, but then this 4 is ruining it all, right? So if we move 4 to the left side, then it will be xm minus 4, right? So xm minus 4 is less than or equal to 2 to the 20th power over 1. No, so 1 over 2 to the 20th power. And so let's just say that this is equal to a separate value, right? So let's just say that's a. That's am. This is am. Then xm is equal to am plus 4, right? And am is less than or equal to 2 to the negative 20th power. And so we have those things. And now we can substitute this into these values, into the x's, right? And so if we put that in there, then that gives us that an plus 1 plus 4, right? Because x is am plus 4. This equals that equals an plus 4 plus 6, and then an plus 4 squared plus 5 an plus 4 plus 4, right? And so this gives us all over an plus 10, and this is going to be an, so that's going to be an squared plus 8 plus 5, so it's 13 an plus 40, right? And so that would go up there. And so this is going to be equal to am plus 10, no, and so this is am plus 1 plus 4, right? And so if we move plus 4 over there, then that's going to be am plus 1 is equal to all over an plus 10, and this is going to be equal to an squared plus 13 an plus 40 minus 4 times an plus 10, right? And so 40 and negative 40, those two cancel, and so 40 is going to go away, and minus 4 times 10 is going to go away, and so we have minus 4 an, right? And so if we get those two away, then that will just be 9 an, right? And so this is equal to an times an plus 9 over an plus 10, right? An plus 10, right? And so an plus 1 equals an times an plus 9 over an plus 10. But then if you see here, am, this is less than or equal to 2 to the negative 20th power. Like, how small is that, right? And so this is going to be a very, 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 very small value, and this is going to be the same very, 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 very small value. And so with the intervals being as large as they are, then it doesn't really matter whether an is in there or not, because this is just plus 9 and plus 10, so this is going to be very, 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 very similar to 9 over 10. And so we can kind of disregard the an, because that will just because that won't have like an impact on our intervals. So we can see that this is similar to, so an plus 1 is similar to an times 9 over 10, right? But then this is basically the same thing, right? And then now we have this, right? And since x0 is 5, that means am, so a0, this is equal to 5 minus 4, and so a0 is 1, right? So a0 is 1, and since an plus 1 is an times 9 over 10, that means an is going to be equal to 9 over 10 to the nth power, right? And so this is an, but then we want am, right? So let's change this to m. So am, this is equal to 10, this is equal to 9 over 10 to the mth power, right? And then this has to be less than or equal to 2 to the negative 20th power, right? And then now we have this, let's say, so let's look at 9 over 10 to the third power. This is 0.729, right? But then 1 over root 2, this is going to be equal to root 0.5, which is basically root, which is something like, so which is similar to 0.7, because 0.7 squared is 0.49, and so so it's going to be very, very similar to 0.7, so it's going to be like 0.71 or something like that, right? And obviously 0.71 is less than 0.729, and so this gives us that 9 over 10 to the third power is greater than, this is equal to 2 to the negative 1/2 power, so 2 to the negative 1/2, right? But then we want 2 to the negative 20th power, and so we have to raise each of these to the 40th power, right? And so 9 over 10 to the 1/20th power is greater than 2 to the negative 20th power, right? But then since these two values are so close together, right, that means this and this will be very, very similar, right? And so since comparing this, m and 120, they seem to be in the same spot, and so m is going to be similar to 120, right? And so since the interval is so large, we don't even have to worry about it, right? And so 120 fits very well between 81 and 242, so the answer is C. Last problem, number 25. How many sequences of zeros and ones of length 19 are there that begin with a 0, end with a 0, contain no 2 consecutive zeros, and contain no 3 consecutive ones, right? Okay, so first of all, they have to start with a 0 and end with a 0. And they have to be length 19, right? And so if they are length 19, we have to find, yeah, so let's put up length 19 things, 7, like that, right? And so that would be 19. And they have to begin with a 0 and end with a 0. So this is going to be 0, and this is going to be 0, right? And inside here, there can be either one by itself or 2 ones together, right? And then they will all have to be separated by 0, right? So so it can be 0, 1, and then 0 and 1, 1, or 0 and 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 0, like that, right? And then they have to contain no 2 consecutive zeros, so this is one of the many possible combinations. And so if you see, they are they can be kind of categorized like this, right? Because all the zeros have to be apart, and the ones can only be in groups of 1 or 2, right? And so if we pair the zeros and the ones together, then they will either be 0, 1 or 0, 1, 1. These are the only 2 possible groups. And if you see, the 0 is kind of left alone, and so we can take this out from the whole thing and see that the length is 18, right? And so this will be the length 18, and 18 is made up of 2s and 3s. So 18 made up of 2s and 3s, right? And so this would be the 2s and this would be the 3s. And so if we just do that, 18 can be divided into 2 and then 3, so 2 times 9, and so that would give 3, 0, and so 6 would give 3, 2, 3, 4, or 0, 6, right? So yeah, this is a 4. This would give just one possibility, right? Because that would be just 0, 1, so yes, because that would be just like 0, 1, 0, 1, 0, 1, 0, 1, all 0 1s, right? So this will just give one possibility. Same thing for 0, 6. This will give only one possibility, because it will just be like 0, 1, 1, 0, 1, 1, 0, 1, 1, like that till the end. So that's just one possibility. But then here we have 2 0, 1, 1s and 6 0, 1s, right? And so for this one we have to do 8 choose 2, so this is 28. And for this one, same thing, we have to do 8 choose 3, right? And same for this one, we have to do 7 choose 3, right? Because out of the 7, we don't know where the 3 will go, so this is equal to 35, right? And so what we have to do is add all these together. So 1 plus 28 plus 35 plus 1 equals 65, so the answer is 65. The answer is C. So that was it for the AMC 10B from the year 2019, and thank you for watching.